In class on Friday, we took a look at another literacy question. Guaranteed, you will always see some type of literacy question on the AP Calculus exam. So first thing I'd like you to think about after you read the prompt, the cost in dollars to produce quarts of ice cream is our function. When appropriate, state the units of the coordinate point or the units of the rate of change. So take a moment. The first two, A and B, are coordinate points, one for the function, one for the inverse. The second two are derivatives, so they are rates of change. So I'd like you to take a moment, stop the video, write the rates of change that correspond to each of the four situations. Hopefully these are the rates of change and the units that you wrote for each coordinate point. So Q is your input, C is your output, that's quarts and dollars. So 200 quarts, $600. The second question, $300, 750 quarts. The derivatives, remember, represent a rate of change. So you need to think about the change in Y over the change in X. Or in our story, we could call this the change in dollars, right, over change in quarts. I guess I should use my variable with Leibniz notation, dCbq. But the inverse rate of change will be dQ dC. Okay, now I'd like you to pause the video, and I'd like you to write two statements, one for the point 200, 600, one for the point 300, 750. What do those two coordinates mean in the context of the problem scenario? Hopefully you said, for part A, it costs $600 to produce 200 quarts of ice cream. And for part B, to produce 750 quarts of ice cream, it will cost $300. Okay, let's talk about C and D. And with both C and D, I want you to think about four things. When, what, increasing or decreasing, a rate with units. Okay, so at what particular time is this derivative talking about? What time is it talking about? It's talking about at the time the company is producing 200 quarts of ice cream. Okay, what is changing? What is increasing or decreasing? Okay, so if we're talking about this rate being $2 per quart, okay, well that's my rate with units, but what is changing? So always look back at the prompt. What are we talking about? We're talking about the cost to produce quarts of ice cream. So what is changing? The cost to produce quarts of ice cream. How is it changing? Is it increasing or decreasing? This is a positive value, 2, so we know the cost to produce quarts of ice cream is increasing. At what rate? At a rate of $2 per quart. Okay, so here I have underlined in black the when. At the time the company is producing 200 quarts of ice cream, what is happening? The rate of change of cost in production is doing what? Is increasing at a rate of $2 per quart. So I'd like you to pause the video, and I would like you to interpret D the same way. Decide when, decide what, decide increasing or decreasing, decide at what rate. Okay, after thinking about this, hopefully your mind is pretty clear. At what time, at the time production of quarts of ice cream costs $300, the rate of change of production of quarts of ice cream is increasing at 0.7 quarts per $1, or you could say 7 quarts per $10. Look those questions over. I guarantee on every AP exam that you will take for BC or AB calculus, you will see an interpretation of a rate of change. Okay, the next thing we did on Friday in class was we talked about the definition of derivative at a point and refreshed our memory about what that equation or expression looks like. So we refreshed our memory and said, remember, it's a limit as h approaches 0 on my function f of x plus h minus f of x. Remember, that's a change in y right there over h. Okay. Oh, I forgot. I'm supposed to do it at the point when x is equal to 5. So what's going to change about this story? We're not going to have an x in there this time. We're going to have, actually, the x value of 5. Okay? All right, if we could evaluate this, this would give us the derivative of the function at the x value 5. All right, let's take a look at s of t. We want the derivative of this function s of t when t equals 3. So we're going to say the limit as h approaches 0 of I'm writing a little template here because the first thing I need to find is s of 3 plus h. So do you see how I wrote a template for my function, leaving space to insert for t the expression 3 plus h? Then I'm going to subtract my function, which is s of t, and I'm going to put that difference all over h. So that one's a little bit of a mess there, but that is the definition of derivative for this function s of t at t equals 3. Okay, can you pause the video and can you write what function is this limit expression using, and at what point is this limit expression finding the slope or finding the derivative? Okay, hopefully you said it's just the function q of t at t equals -6. Let's take a look at a few more. All right, this top one is a little messy, kind of like that s of t situation we were in. So I'm just going to highlight or put a box around that 2 plus h expression that I see a couple different times. Remember, with the s of t scenario, I left a space to plug in, what was it, 5 plus h or 3 plus h or whatever it was, okay? So where I have these red boxes, that really represents what used to be my variable. So I could say f of x in this story is, oh, something got cubed, x cubed, minus 7 times something squared, plus 9. Okay, what is this 13? Where did that come from? Well, at what point am I finding the derivative? According to this story, it's at x equals 2. What is f of 2? It's 8 minus 28 plus 9. That happens to be 13. Or did I do that wrong? That would be 20. Oh, it should be 11? Okay, my bad. That should be 11. All right, just double checking. That's 2 squared is 4, negative 28. That's a negative 20 plus a 9. Oh, it should be negative 11. Sorry, I'm making a mess of this. So negative 11. So this should turn out to be plus 11. Remember, because it's minus negative 11. Okay, sorry for that mess. The next two are a little bit simpler, so give these a try. What is the function? What is the point at which you are finding the derivative? Okay, if you said f of x is the natural log of x and x is equal to 4, you are correct. If you said f of x is equal to the cosine of x and x is equal to pi thirds, you are correct. What is the cosine of pi thirds? It is 1/2. Okay, moving on. So on Friday, we took a look at, there was a homework question, number 9 on the worksheet, that you were not able to do unless you knew how to find the derivative of a polynomial straight away without using the definition of derivative. So let's use the definition of derivative on f of x equals 3x squared minus 5x plus 1 and see what's happening. And we're going to look for some patterns. So I'm going to start out. F prime of x is equal to the limit as h approaches 0 of 3, I'm leaving some space, minus 5, I'm leaving some space, plus 1 minus 3x squared minus 5x plus 1 all over h. Now, what's going in those spaces? What's going in those spaces? X plus h. Okay, we're going to do a little algebra. We're going to simplify this. We're going to cancel some stuff. So x squared plus 2xh plus h squared times 3 minus 5x minus 5h plus 1. Be careful of your parentheses so you don't lose any negative signs. I'm going to distribute 3x squared plus 2xh plus h squared. Oops, sorry, I got to distribute it. 6xh plus 3h squared minus 5x. Oops, that should be an h. Minus 5h plus 1 minus 3x squared minus 5x plus 1 all over h. Okay, remember when I said earlier in the course that f of x always drops out? And it does. So what do we have left? We have the limit as h approaches 0 of 6xh plus 3h squared minus 5h all over h. I'm going to go one more step. For those who need this step, I encourage you to do it so you don't mess up the algebra of this. There's an h in the numerator that will cancel with an h in the denominator, and now I can take the limit as h goes to 0 and get 6x minus 5. So if we take a look at our function, 3x squared minus 5x plus 1, its derivative is 6x minus 5. Okay, that should make some sense because y equals 1 has 0 slope. Y equals negative 5x has negative 5 slope. What about this 3x squared? How did it become 6x? Any idea? Well, we know the exponent has to decrease by 1. That makes sense. But why did the 3 become a 6? Any guesses? The exponent 2 comes down to the coefficient, and we get 2 times 3 is 6. Let's look at the pattern. Starting at the bottom of the list here, the derivative of a constant is 0. And you guys know that. The derivative of a line is just the slope of the line. The slope of this line is 1/2. The derivative of a quadratic, this would be f prime of x equals negative 14x plus 6. And f prime of x for this cubic would be 12x squared minus 10x plus 9. Here's the power rule. The exponent comes down in front to join the coefficient and gets multiplied. Then you reduce the exponent by 1. You will need this to answer 9C on the homework. Good luck. See you tomorrow.